Hello there, and welcome to your first video of Unit 4. Unit 4 deals with two-variable statistics, which means you are comparing the relationship between two variables. The graph that we would be examining in this unit would be the scatter plot, where you would have one variable on the x-axis and one variable on the y-axis. So we're just going to review some of the basic terminology that you learned in grade 9 when scatter plots were introduced, and then what we're going to be doing is going into some calculations later on in the video. So to start with, a scatter plot is a graph illustrating the relationship between two quantitative variables. That's important. Quantitative means they have to be numerical variables, so you can't, for instance, have a scatter plot with eye color on one of the axes. Both variables have to be numbers. It is particularly useful when the variable on the y-axis is thought to be dependent upon the values of the variable on the x-axis, which is the independent variable. Visually, scatter plots provide the following information. They provide the correlation, which is the clustering of data points along a line. When you look at correlation, what you're looking for is it positive or is it negative? Or is there no correlation at all? You are also looking for the strength of the correlation. So is it strong? Or is it weak? So anytime you are asked to describe the correlation, you have to talk about the direction and the strength. As well as that, you also want to talk about the type of relationship. For instance, is it linear? Or is it nonlinear? Nonlinear relationships could be quadratic, exponential, logarithmic, if you've taken advanced functions. But in this course, we're really just going to stick to, is it linear or is it nonlinear? You also want to look at the presence of outliers. Of course, those are data points that emanate from a different model than do the rest of the data. Outlier detection is important for effective modeling. Later on in the unit, you'll be learning how to calculate which points are outliers. When data is displayed with a scatter plot, it is often useful to attempt to represent the data with the line of best fit, or what is also called the trend line. There are different types of lines of best fits, but the typical line of best fit that we will use is called a least squares line. This is a straight line that best represents the data for purposes of predicting values that may not be displayed on the plot. So if you remember from grade 9, you may be asked questions such as, if you had 15 years of experience, then what would your income be expected to be? In a case like that, that is what we call interpolation. Interpolation is when you make a prediction within the range of the data. So if your data starts here and ends here, we are making a prediction within that range. Conversely, extrapolation is when you make a prediction outside the range of the data. So you may be saying if you have 40 years of experience, what would your income be expected to be? So that would be extrapolation. When a scatter plot shows an association between the two variables, there is not necessarily a cause and effect relationship. So there definitely may be a relationship between the years of experience and the income, but increasing the years of experience does not necessarily cause the income to increase. It may have an impact, there may be a relationship, but there may not necessarily cause that to happen. Different types of relationships like this will also be talked about later on in the unit. So let's review the different types of correlation in more detail. So to start with, a positive correlation. As the values of the independent variable increase, so do the values of the dependent variable. So basically, it increases from left to right. The closer the points are to the line of best fit, the stronger the correlation. So in this first scatter plot here, all the points would be on the line of best fit. So that would be a perfect correlation. In the second scatter plot, the points are close to the line of best fit, so that is a strong correlation. Please ensure when you are talking about strong correlations, you say points are close to the line of best fit. What you do not want to say is points are close together. So that is not how you describe a strong correlation. To describe a strong correlation, you say points are close to the line of best fit. A weak correlation is when the points still seem to be making a positive trend, but the points are further away from the line of best fit. So that is a positive correlation. A negative correlation as the values of the independent variable increase, the values of the dependent variable decrease. So basically the lines are decreasing from left to right. Once again, the closer the points are to the line of best fit, the stronger the correlation. So you could have a perfect negative correlation. You could have a strong negative correlation, or you could have a weak negative correlation. No correlation is when the values of the dependent variable are unaffected by the values of the dependent variable. So if you look at your scatter plot and you really cannot decide whether the points trend upwards or downwards, that's when there would be no correlation. So very low or zero correlations may result from outliers. Remember, when making conclusions, the outliers may or should be removed. So you may want to remove the outlier. You may want to keep the outlier in. Hopefully what you'd want to know is why that outlier exists. Was it a mistake or was it just a real point, just vastly different from the others? Either way, the outlier should be mentioned in your conclusion. So what tends to happen is one outlier can seriously skew the line of best fit. Be very careful. Outliers are points that are far away from the line of best fit. So this point is considered to be an outlier because it's far from the line of best fit. This point here is not considered an outlier. Even though it's further from the points, it still follows the trend. So be careful when discussing what an outlier is. An outlier has to be far from the line of best fit. If it still follows the trend, or if it's still close to the trend line, even if it's farther away from the other points, it's not considered an outlier. So, nonlinear relationships. Very low or zero correlations may result from a nonlinear relationship between the two variables. The points may be clustering around a curve and not a straight line. So sometimes when points seem to curve, a curve of best fit would be a better option than a line of best fit. In this course, we're only going to be looking at lines of best fit, but what I'd want you to know is that it is possible that a curve of best fit would have been a better fit. You are not responsible for making a curve of best fit or finding its equation. You just need to know that a curve would have been better than a straight line. Not examining the proper trend of the data may cause improper interpolation or extrapolation. Not examining the nature or the future of the relationship between the two variables can cause improper interpolation or extrapolation. So the future meaning if the trend line were to continue when you're getting into extrapolation, the trend may not continue past the data points. The further away from the plotted values you go, the less reliable is your prediction because you are really just guessing what the points are going to be. You don't know for sure. So that is it for part 1 of the video. Please ensure that you watch part 2 of the video. In part 2, what we're going to do is learn how to use a calculation to determine the strength of the correlation. So please ensure that you watch part 2 of the video. Thank you.